I'm Chris Bond, and I'm the founder of Thinkbox and now director at EC2 at AWS, where I direct and manage the Thinkbox team and basically help bring studios to the cloud and help them work with the production pipelines. So what I wanted to talk about today was sort of state of where we are, what's been happening, trends that we've been seeing, some solutions that our customers have been doing, talk a bit about the show, our booth, and what else we're going to be talking about today. So a little highlight, and then I also have Jason Fodder here from Fuse FX, who will be talking about their experiences and solutions scaling up their render farm. So when we talk about production in the cloud, you know, I come from a visual effects background. I owned a studio, did a ton of rendering for broadcast, feature films, worked on about 42 feature projects. And you know, the biggest component of that in terms of time and constraints was rendering. So when we talk to customers now about rendering, you know, traditionally you would have an existing on-premise infrastructure, a render farm. You'd use your workstations at night, presuming you didn't have a night crew or something, and a bunch of machines in a closet somewhere. And over time, you know, these companies that were successful built a larger and larger infrastructure. And I remember a time when you would bring studio execs or customers to your offices, and you would show them this glass enclosure and be like, look at our cold room and all of our gear. And now I go to customers, I go to studios, I go to boutique facilities, and we talk about those days, and they say, you know, I haven't shown anybody our infrastructure in like 5 years. Nobody cares. Now it's off-site, or it's in the back closet somewhere. It doesn't have glass anymore with flashing lights, because it's not about the infrastructure, it's about the talent and the artists. And so because of this, we've been seeing a change. And I remember a year ago, about a year and a half ago, we were acquired by AWS, and I would talk to customers and they'd say, why should I go to the cloud? Tell me why I should burst and do things. And today the story is a little different. But let's talk about the trend that we're seeing. So the first trend is our customers want a hybridized rendering pipeline. So they realize that they want the cost savings, elasticity of bursting to the cloud. They want that flexibility. But at the same time, they still have an existing on-premise infrastructure. So they have, that monitor went out, it's back. They have on-prem render nodes, they have an asset file server, they have their workstations, they have a connection, but they want to scale that up. And so their choices are they can, you know, spin up a bunch of machines in the cloud and build another infrastructure, or what we're seeing the trend be is they're building a hybrid rendering pipeline. And so essentially, this is an example. There's several ways to set this up, but this is the Deadline 10 AWS portal example, where when you install Deadline 10, you connect directly to the cloud, you synchronize your assets to S3, and you render and extend your infrastructure. This shipped in Deadline 10 in August of last year. So when I talk about rendering on the cloud, I always talk about EC2 Spot. That's the organization that I'm a part of, that our team is a part of at Thinkbox. And people say to me, what is Spot? And a lot of people haven't heard of Spot. So I want to talk a bit about what Spot is in reference to the rest of the Amazon EC2 compute. So you're probably familiar with OD instances. These are on-demand instances on the AWS cloud. And they're essentially machines that you pay for a period of time, and you don't have a long-term commitment. RIs, a lot of people aren't familiar with those either. RIs are reserved instances. So think about this as machines that are essentially yours 24/7, and you generally commit to a period of time, a commitment. And there's a lot of flexibility in here in terms of where those RIs exist, whether you can move from RIs, whether they're dedicated hosts that are bare metal, what the commitment is, and there's a marketplace as well, so if you oversubscribe to RIs. So think of this as like infrastructure that you effectively own that's yours for 24/7 access. So this could be like a core infrastructure on the cloud. Spot instances are a little different. So Spot instances are Amazon spare capacity. So at AWS, we have all of these other type of instances, but they're not in use 24/7. So we have a number of instances that are accessible. And so what we do is we provide them to you at 90% off on-demand prices. And the only caveat is that we can give you a 2-minute warning and take them back. So if somebody says, oh, I want 400 on-demand instances, it might get pulled from the Spot instance pool. So that being said, we made some announcements at reInvent last year. And people think of EC2 Spot, they think of a complicated tool set to use. Well, first off, Deadline 10 supports EC2 Spot out of the box. We added something called AWS Portal, and that lets you access EC2 Spot by default in Deadline, so you don't have to do anything. As well, if you have your own existing pipeline, your own infrastructure, you've built your own render farm with your own software, it's pretty easy to get access EC2 Spot through the API. Now, people also thought that you used to bid on Spot, and this was the case. There was a period of time when you would bid to compete with other people for those Spot instances, so that spare capacity price would fluctuate a lot. That changed in November of last year. So now there's no more bidding. It's just a set price by AWS so that we can manage and shape demand. Additionally, we added pause and resume, stop-start options, and hibernation, and I'll get to that in a second. So as I was saying, this is a screenshot of Deadline 10. And it ships with a new portal called AWS Portal. It just connects you directly to the instances on the cloud, where you can choose those instances and set the price, et cetera. Back to the pricing, as you can see, November 29th, this is the on-demand price. So people had all of these strategies to ensure that they got the Spot capacity that they wanted to. And they would set the price close or 90% of on-demand and bid against each other for certain instance types. And you can see on November 29th, that all changed. So now the price fluctuates incredibly slowly based on demand and how people are using their instances. And we update the price only once per day. So essentially, you can just purchase Spot, get 90% off, and you don't have to worry about bidding. You just leave that alone. And then people always say to me, like, well, what about interruptions? How do we know that we're going to get this capacity or this access? So we looked at some of the data. And as you can see the stat here, the majority of Spot instances are terminated by people because they're completing the job. And so, with the feature of Hibernate, a lot of these concerns also go away. So Hibernate, if you initiate Hibernate when you launch the instance, it'll actually copy what's in memory to the EBS volume. And when the instance gets shut down, if it gets interrupted, it'll essentially be like closing your laptop lid. So when we get capacity again, it'll come back up, take the data from disk back to memory, and restart. So if you're doing a long simulation and you're really concerned that you really need 24 hours, you can either choose on-demand or use something like Hibernate and Spot to ensure that your project doesn't get interrupted. So customers are using Spot to scale up. And what we're seeing is that they're essentially not just using this to add a little bit of compute, but actually to say yes to customers. So we have a customer here named Passion Pictures out of UK. And they're using a competing render farm product with their on-prem machines. They got a number of other competing jobs at the same time. And rather than tell the customer, we can't do that, they said, you know what, I think we can. And they switched to Deadline on-prem during production and scaled up and doubled their infrastructure in just a few weeks. So they added essentially 200 cloud instances to finish up their projects. So this is the kind of thing we're seeing, but it's not really what we expected. So when we first started out at this, we looked at on-prem data from small, medium, and larger studios that use Deadline. They're kind enough to share it. And you can see in this graph, this is a week, this is a 5 days, Monday to Friday production period of a small studio, and these are all submissions. And you can see at the left, it goes up to 24 hours. So the majority of submissions are happening 5, 10, 20 minutes, a number at 6 hours, 4 to 6 hours, and then some are peaking at 18 to 24. So, I've got a boss, we all have bosses. So my boss said, how are we going to get these people to experience elasticity of scale, the production of the cloud, and how is that going to help them work? And I said, having owned studios, what they're going to do is they don't want to wait 24 hours. So they're going to push this stuff to the cloud, because there's no way that they can scale their infrastructure fast enough to get those jobs done in the time period. And when we looked at larger studios, this is one day at a big studio, and the graph goes up to 48 hours. So there's a higher frequency of larger jobs in these large studios. And again, I said, so these big studios, we're going to get more of their work because they have these jobs that are taking 24 to 48 hours, but they're going to like scale up this. This is what I told my boss. So, you know, sometimes we get it wrong, and this isn't really what's happened. Instead, what's happening is customers are doubling, tripling, quadrupling, and even in a few cases this year have 10x their on-prem capacity. And so below in this graph is an example where I took a customer data set and I looked at the change. And the idea is they don't want to wait 24 hours. They don't want to wait 12 hours. They certainly don't want to wait 48 hours or a week. They want everything to happen as soon as possible. And because you're paying the same per second billing on AWS on these instances, because you're paying the same whether 1,000 machines are rendering for 1 minute or one machine is rendering for 1,000 minutes, the idea is that you just scale up the infrastructure. So the top line is the number of machines that we're seeing customers add and scale to their infrastructure. And the bottom is keeping everything down at 2 hours. So they're splitting up 1 frame per machine or bundling 3, 4, 5 frames depending on the job. Even splitting up frames or pixels to lots of instances. So what this means is that the variable is time instead of how much computers can I cram in my closet. And so we have a customer here today who's going to be talking to later on, and I think it's a great example, where they essentially, what did they add? 130,000 cores at peak. So they essentially, I believe, 9x'd their on-prem infrastructure for this project. So we're in the middle of a drift, and there's a demo reel that was playing earlier, and hopefully they'll play it during their presentation. They talk about how they broke down the show. Some amazing fluid simulation work. And if you know what that kind of work is like, it's very compute intensive. And so in order to scale this on-prem, this small team would have had to add an enormous amount of compute capacity, which I don't believe, I mean, if I know anything about London, UK, you know, they didn't have the space, didn't have the cooling, or anything like that. And I don't know, maybe they'll talk about it and tell us exactly what they had. So this is what happens. We're seeing people turn a dial in the knob in a way that we didn't expect. I thought for sure like 10 or 15% of the compute would happen on cloud. Customers are doing double, triple, 10x. And I'm not just talking about one. We've had at least 3 or 4 customers this year scale up 10x. In fact, what's really interesting is that all of the rendering done at AWS last year, if you take all of it, as of July, 6 months to the end of July, 6 months of the year, we already had 6 times that amount rendered on AWS. So the trend is going in the direction of shifting more of the workload to cloud and saying yes. And the customers are doing this not because they made mistakes or, well, that happens too, and I think there'll be a story later about a problem, but because they're taking on bigger challenges and they're adding capacity and customers. And we even had one customer who did a second film when normally they would say no, and they scaled up. So what happens when you scale up on the cloud? Well, you have to scale your storage, and this is something that people on-prem really don't think about, right? Because if you have 200 machines, you've built storage to a capacity that sustains an amount of work for those machines. If you have 2,000, same thing. You've sort of built that over time, and you've gotten to a point where it's sort of the minimum acceptable performance, right? And I see this all the time when I go to studios. And I remember my employees would come to me at 3 o'clock in the afternoon and go, what's wrong with the farm? There's something going on every day. The network gets so slow at 3 o'clock. And what it was every artist was submitting jobs to the queue and trying to get their last renders out before they go home at the end of the day, right? Because they want to render overnight. And so the performance would fall apart. So we try to build this infrastructure that would support the artist, but we were growing at the same time, and it's just, you didn't exactly know how much you needed, et cetera. So this is where the cloud gets really interesting. So first I want to talk about, again, our hybrid rendering pipeline on Deadline 10. So Deadline 10 ships with a set of tools that allow you to connect securely to the cloud, and part of this is synchronization of assets to S3. So what happens is an artist submits the job, their local asset server at the time of submission within Deadline looks at the list of assets that the scene requires. It then passes that list through the secure connection to the cloud, to the infrastructure that comes in Deadline 10 on AWS. And it will then synchronize the assets that don't exist already. So if you've already submitted the job, the second time you submit it, you're not going to synchronize the assets again. It'll only synchronize any changed assets. So you change a texture or a cache, it'll synchronize. They're all copied up to S3, and when each instance is started, what we basically do is rely on the backbone of S3, and we copy the assets that every slave needs to the local EBS volume of the machine. So essentially, there's no centralized high-performance file server or cache. We're just using S3 to copy the data to each instance. What's interesting about this is we also have a failover where we'll synchronize the data. When the slave accesses the files, because you're connected through a secure connection to your on-prem infrastructure in this hybrid manner, we'll actually look at the files, and if something's missing, it'll do a callback and bring that asset up through the file system. So as long as it exists on your local infrastructure, the renders will succeed. And that way we capture things that perhaps Maya or Max or Nuke or whatever don't list in their asset directory, texture caches in Arnold or something. So, but when we're talking like 3,000 instances, or scaling up for 3,000 or 5,000, and we have a demonstration of this later today, and at our booth, you want to do workstations in the cloud. So you're not worried about synchronizing data, but you want to be able to scale your infrastructure. So we have solutions for that. So we have two partners here today, Weka and Cumulo, that are at our booth. And what's really great about these companies is that they're building solutions for file storage on AWS that leverage the elasticity of the cloud. What's really interesting about Weka, for example, is that it can tier to S3. So if your data is copied to S3, you got it in Glacier, you pulled it back up to S3 for storage, you've synchronized on-prem to S3, for example, you can build a flexible infrastructure, a flexible storage infrastructure that scales on demand for your needs. So Weka on Linux can support up to 7 gigabytes per second to a single instance. And it can do that by scaling up a ton of instances. And you can even use Spot. Because you're getting the data from S3, what happens is a machine says, oh, I need this file. The metadata will get copied over. That'll be the first thing to request from S3. It'll go to the cache nodes, propagate, and scale up. So we've seen customers successfully use Spot. That's right, Spot, 90% spare capacity instances as the cache layer for Weka and spin up hundreds of instances. So when I talk to customers like this, they're sort of like, wait, what? I can do that? Because when you're on-prem and you're like, I've got an Isilon, I've got 2 Isilons, I've got 10 Isilons, I've got a bunch of, dumb boxes that have just a lot of RAID disks or something, and they're just used to like, this is what they have. They have a terabyte of this, or a petabyte of this. They have 2 petabytes of that, and this is their storage. And when I say to them like, oh, you can scale the storage, not just the amount of storage, but also the performance of it. So when you need to spin up 50 artists to work on a 16K project, you can scale the capacity so nobody feels the difference. And another partner, Cumulo. So we have a customer here today who's going to be talking shortly, Jason Fodder from FuseFX, and I'll let him get into more detail about Cumulo, but they use Cumulo. So my understanding is these guys have a very simple, configurable solution that lets you manage and scale your infrastructure in the cloud. So you can replicate data between different regions. You can use your on-prem client. It's got support for Windows. They have on-prem infrastructure that can synchronize to the cloud. So this is another solution we're demonstrating at the show. In fact, we've got this tied as the back end to our visual effects workstation. So at our booth, number 701, we're doing a live demo of visual effects workstations with Cumulo-backed storage. So I'm pretty excited about that because we're on the show floor, so we'll see. When everybody's like using the internet, we'll see what happens. But this will be a good test, right? And then the other component of this cloud infrastructure is software. So I'm briefly going to go over our marketplace. So one of the things that you have to think about is, if I'm going to scale, how do I buy 1,000 licenses of V-Ray or Arnold or whatever? And some of these customers or partners have solutions. Many of them don't. Some of them, the smallest amount of time that you can get a license for is a month or maybe a week. And you have to go through a process. So we built something called the Thinkbox Marketplace. And the Thinkbox marketplace essentially has a number of common products. We're going to announce new set in a few moments. We have a number of partners from Arnold, Max, Maya, Katana, Nuke, V-Ray, Redshift, and RealFlow, Yeti. And you can purchase bundles of hours that every machine will consume in minutes. So if you buy 1,000 hours and you have 60 machines running for 1 minute each, you would consume 60 minutes or 1 hour from your bucket of time. What's interesting is that Deadline 10 supports this by default. We have default AMIs of common tools so that people can get started. We also have a great webinar we did last week where Bobo shows how to customize your AMI. I didn't explain what AMI is. That's an Amazon machine image. And so it's what software is deployed on the cloud instances. So in Deadline 10, we have predefined, like a Deadline 10 in Linux, a Deadline 10 in Windows, Deadline 10 with V-Ray, Maya, et cetera. And if you need to install the latest plugin or a different version, you're using the daily build of V-Ray, it's very easy to boot up a remote interface, access the machine, install your own, and then you can now save that and use it yourself. But we also support bring your own licensing. And we support a hybrid way of bring your own licensing and UBL. So we know that you guys have 100 seats of V-Ray or 1,000 seats of V-Ray on-prem. So we want to scale to 3,000. You can still use those licenses first in a preferred way. In Deadline 10, we have a license limiting system. You set a cap of I want to use 100 licenses, and then I want to go to UBL beyond that, up to a certain capacity cap if you want to. So you have a lot of flexibility there. And if you don't want to use Marketplace, you can still use bring your own licensing. We don't want to get between you and the vendor. We just want to offer a solution for customers who need to scale and get that elasticity, and they don't want to invest in thousands of licenses. So one of the other things that's changed, so we've been acquired by AWS. It's been a really interesting time. The great thing about AWS is that we're really focused on the customer, scalability, elasticity, cloud, but we're still building things for on-prem. So we don't have like a Deadline 11 because at AWS, you constantly are deploying new versions. So we're getting into a cadence where we're releasing every 2 weeks, and we don't hold back features for some artificial delivery where we say, like, look, there's all these things. Instead, we just constantly are adding improvements. So between fixes, improvements, maintenance items, support for new Max and Maya, et cetera, these are some of the out of hundreds of items that we've added in the last year. So the ability to launch across availability zones, multiple licenses for orders, stuff for on-prem infrastructure performance. We've done things in the GUI. We have customers who have hundreds of thousands of jobs in the queue, and they want to be able to work faster and tag them faster inside the Deadline Monitor. So things, improvements like that. So we're investing in on-prem, we're investing in cloud, and we're investing in security and stability of Deadline for the future. So I said we had a couple announcements of partners. So we have Keyshot and Clarice now in the marketplace as of today. We just had a build go out. So now we have more partners. We're going to be adding more. So if you have tools or plugins or applications that you use and you want to see per minute licensing, talk to us. We have a partner manager, Chris Bober, and he's been working with people like Keyshot, like Lexion, and Clarice on this for a little while, and we'd love to get more partners. So we hope to have more announcements coming up next, but come see these guys at our booth. We'll be demonstrating. And a quick shout out to our booth partners. So at AWS, we're all about partnerships. So we've got Autodesk there, Redshift, the hardware rendering on our GPUs is fantastic. We had some customers who had a similar thing where they needed access to 500 GPUs. They scaled to AWS to render their project. We've got the Weka, Cumulo for file system performance, and Teradici for streaming technology, as well as Keyshot. And then later on today, we've got Mikros, which is a very interesting story. Sherlock Gnomes, 170,000 cores, 4 million plus hours rendered on AWS. So we're going to hear about how they built that infrastructure and pipeline, how they did the project. Milk, coming up this afternoon. They're here. I'm super excited to hear their story. 130,000 cores. These guys scaled like 9x from their pipeline. I hope they got that right. We're going to be showing visual effects workstations, how to set it up. So this is one of the things that's the trend that we've been seeing. So I said a year and a half ago, folks would say, well, convince me why I need to add cloud rendering. And this year, I was at NAB, and all our meetings were, how do I move my entire studio to the cloud? Or how do I add another team in Montreal or wherever? You know, we have regions all around the world. We have data centers close. We have solutions for workstations. We have workspaces, AppStream. We have partners like Teradici. We can help you guys build a virtual studio in the cloud. All the components are there. We have security approval with ISC. We're talking about this afternoon for burst for production and for asset storage. So people can store long-term assets for content on AWS, and we have a security template for that. There's an artifact. So they'll get into that. So all of these pieces are coming together, the software, the workstations, the licensing, security, and of course, all the rendering and capacity. We also, as part of AWS, have Game Tech coming this afternoon. So they're going to be talking about all the different components of Game Tech and how that works. They're going to be demonstrating high fidelity, realistic terrain for games. And WeatherBug is going to be here doing real time. I saw a little demo of AR thing with their phone. Looks pretty interesting. So that's this afternoon. So with that, I'm going to introduce Jason Fodder, CTO and co-founder of Fuse Effects, so that he can talk a bit about his pipeline, his experience with AWS in the cloud, and how he manages production. But before we do that, we're going to play his reel, because I think that's the best way to introduce him. So if you could cue that up, that'd be great. Thanks.
Thank you. Thank you, Chris. Jason Fodder, Fuse Effects, co-founder and CTO. I'm here today to talk about how we're leveraging the Amazon cloud for burstable rendering and like Chris mentioned, being able to scale your production workload to meet really any demand within any period of time, and going to go and get into a little bit about next steps and what we are looking at in relation to the cloud for furthering our journey into cloud production. A little background about the company. We were started in 2008 with myself and two other partners, Tim Jacobson and Dave Altino. And we set out initially to do great visual effects. It was an interesting time in the industry. The country was in a recession, but we could see that television was still going strong. There was a lot of content being created, lots of opportunity, and we started early on focusing on efficiency and creating great visual effects. And today, we've been lucky enough to win some awards, lots of nominations, focus on television still, and we're up to a little bit over 300 employees now, and we have offices in Los Angeles, New York, and Vancouver, and working on, anywhere of 100 plus projects at any given time. A couple of our employees are going to be doing some presentations with the folks at V-Ray and Autodesk, if you're interested in that. Lost in Space and Luke Cage will be part of those presentations. Little slide here that I like to show talks about the industry in general. We all know Netflix, Amazon Studios, Hulu, the networks. These companies are creating more and more and more content, more specialized, more shows, more work out there for companies like us. And we're just seeing this tremendous growth in the industry and this tremendous uptick in content. But they're also wanting to do it at 4K. They're also wanting to do more complex visual effects, things that we would not have tried a few years ago or now just part of our everyday world. And so it's really pushing companies like us to develop workflows that can expand and expand quickly. So the cloud really lends itself to that for us, and it becomes an incredibly powerful tool. A lot of things like Chris said, with being able to just expand your workflow on the fly, on demand. I'm going to get into some of the details of how we do that. This is a diagram of our overall workflow. On the right-hand side is our on-premise infrastructure. Obviously, on the left is our cloud. And I want to start with talking about pre-cloud days. So when you're starting a visual effects company and you get into doing visual effects, you immediately realize that you need lots of storage and you need lots of rendering. And when you're on-prem, you have to pick a finite limit of how to plan and purchase and implement that kind of infrastructure. How much storage can I afford? How many render machines can I afford? What kind of network can I design? And you target a threshold of like, okay, I think in the next few years that's where we're going to be. And then clients call, and then they want to give you more work, and then they want to change the scope, and they want to do more, and then they change their delivery dates, and you're like, oh man, I didn't plan big enough. And then it's very hard to expand localized infrastructure. We all have power limitations, cooling limitations, time, getting rental machines into the facility sometimes takes 24 to 48 hours. And you can only do maybe 100 or so, depending on our power limitations. Other companies may be different. But nobody has infinite capacity on-prem infrastructure. And so that's why we started to look at the cloud, and we started to think, maybe we can do this setup where we can create a system to burst into the cloud, and let's see how that goes. And we've been very successful at doing that. And in our world, Nucleus drives a lot of that for us. It's a proprietary development platform that we've created from the ground up. And we have control over our entire infrastructure in our complete file system. And so we know every file on the network and what it's for and where it needs to go. And so we were able to push data around, and that really became the building blocks of being successful in cloud rendering, because you can spin up compute instances pretty easily, but you need to get your data there. And that's why we started talking to Cumulo about, can we get a file system in the cloud? Visual effects is a file-based workflow. When companies come talk to me about object storage, I'm like, oh, it sounds great, it sounds cool, but I need a file system. And I need a high-performance file system because I'm going to have hundreds or thousands or tens of thousands of machines hitting that at one time. And so it can't be the bottleneck that slows renders down. So we run a Cumulo cluster in the cloud, and then we have a custom AMI that matches our local workstation that will spin up any number of spot instances to meet the demand. All that stuff comes back on-prem, and then when our cloud system is done, we're able to terminate it, and it goes away. And that's something that really excites me. We talk about all this cool technology, all this cool, ways to spin up cloud, but from my perspective also, returning machines, returning rental infrastructure always gets complicated, and you always keep it longer than you need. And I get a lot of satisfaction of hitting that little red button and terminating these virtual instances, and then in an hour later turning them back on if we need them. So this is a graph last year, right around this time, showing our usage on the Amazon cloud. And I like showing this graph because it tells an interesting story. I said earlier about productions and needs of production, and for those of you who are in visual effects or media and entertainment, you know what I'm talking about. And it can be a whirlwind sometimes of, you want this win, you need this win, oh my gosh, we've changed our due date, oh my gosh. And then you also have internal challenges. And sometimes people make mistakes, and sometimes things happen. You submit a render to the farm and it's the wrong setting, and the shot was due today, and now what do we do? And now the farm is backed up, and now you're last in the queue. And we have to react to those kinds of challenges and situations all the time in the world of Fuse Effects. So last year, we were working on the tick, doing lots and lots of shots. And early August, we were kind of rolling along pretty good. And then you can see we started to pick up, and we started to have these burstable moments of render needs. And you can kind of see it starts growing. And towards the end of the month, that last, on September 28th, we hit over 9,000 usage hours. The day before, we had a really big delivery, loaded up the farm, put a bunch of jobs on the render farm, and had a plan overnight, and we're like, we're gonna come in the morning and we're gonna be good. We're gonna get our deliveries done and move on. That's normally how it goes. Had some problems the night before. Jobs didn't render, some things were failing, came in the morning, and the queue was just stacked. There was job after job after job that had not rendered. Producers and supervisors come into my office, their eyes are really big. Jason, what are we gonna do? We have to make this delivery. We can never call the client and say we're not gonna make it. And I was like, well, let's say go. Let's dial up the cloud and do exactly what we need to get the job done. And we did. And in a matter of 5 hours, we had 1,000 instances running, got through those renders, got them done, and it was like it never happened. And that's, to me, I like talking about that story because it's a real world situation. It's not theoretical. We really did it. It really happened, and we made our delivery. And that's what it's all about. You have to make deliveries in this world. So it's really exciting to me to be able to say that. And now we're looking at, okay, we did that. What happens if I need 10,000 machines in an hour? What happens if I need 50,000 machines in an hour? And when you're designing something like that, back to visual effects being a file-based workflow, you need fast storage. And when you're talking about 10,000, 50,000 machines, there's not a lot of companies that have that kind of on-premise compute power. In our local infrastructure, I have about 500 to 600 machines, a 1.2 petabyte Isilon cluster. It handles it pretty well. But when you're up in those levels of machines, your network and your storage are incredibly critical. And when you think about storage, these are the 4 metrics that you have to analyze. And I put little dials on capacity, IOPS, and throughput, because those are the dials that we want to be able to turn. And we want to be able to, within minutes, go, okay, I need to go from 10,000 IOPS to 100,000 IOPS. Oh my gosh, I'm running a bunch of Houdini simulations on the cloud. I've got 20 terabytes, I need 100 terabytes. You can't do that with on-prem infrastructure. You can, but you got to call, getting extra nodes of a cluster in is, maybe a month-long process. But companies that are adopting the cloud, companies like Humulo that are embracing the cloud and going, yes, Jason, we're going to take our technology, put it in the cloud, and give you the ability to do this, is incredibly exciting, because now it allows us to think about a limitless approach to infrastructure in the cloud. So I made this diagram of possible scenarios, and what I like about this is it gives us a way to also adopt object storage. So it gives us a way to use something like S3 as the backbone of storage, and then create these independent high-performance file systems in front of it to serve varying loads. So if you've got a small project, you need a little bit of storage, not too, base level of performance, you can spin that up, and you can use that, and then when you're done, terminate it. And then everything will go back to S3, and that kind of lives in its own world until the next time you need it. And let's say that project increases in scope, and all of a sudden you need more storage, you need more throughput. Then spin up a bigger file system, more nodes, more storage, and you can run that way. And then let's say you run into a really big scenario where, oh my gosh, we got to get this all done in a small amount of time. You could do that too. And so this is the kind of infrastructure we're building and looking at and trying to design, because it gives us a flexibility and it allows us to react quickly to our clients' needs. And that's what it's all about. So when I think about what's next, right? So we're rendering in the cloud, doing this cool stuff, meeting these deadlines, getting this stuff done. Rendering is just one component of our process. It's a big one. It's a lot of what drives our infrastructure, but it's one component. And a lot of companies run into the challenge of syncing files. And that becomes now a bottleneck, depending on your network bandwidth, depending on how you're doing it. How many files do you need to synchronize, the data set that you need to do. I mean, we have renders on our farm with varying levels of data sets. A shot might have a few textures and that's it, and that's easy to deal with. Then you might have a shot that references 20, 30, 50,000 different files that you have to manage and you have to move around. And so it's a challenge. We do it. But it's a constant evolving solution internally for us, where we're trying to make it better and better and better and better. But what I like to think about is, what if we didn't have to do that? What if all our desktops were in the cloud, like Chris said, virtual infrastructure, you start to take the approach of, okay, what if everything's in the cloud? Now you don't have to synchronize anything anymore. Now it's all just there. Now you can design virtual infrastructure that can expand to a project's need or a company's need or a location's need. And when things are virtualized, it becomes, you have to think of it a different way. I remember, way back learning what a virtual machine was and what what VMware was. And it took me a minute to get my head around, wait a minute, there's no physical device here. What, I can run 100 machines on one machine? That doesn't make any sense. And you think about it, you're like, oh my gosh. It's it changes the way you think about it. And so I'm starting to think about that with the cloud and infrastructure in general, and the idea of virtual infrastructure and the kinds of opportunities that it presents for a company like us. The other thing that's really exciting is AI and machine learning. Lots of talks here at SIGGRAPH about image-based stuff and image-based machine learning, and that stuff's really cool and interesting and exciting. But there's also leveraging data sets and being able to do that with machine learning. Something that we're starting to look at is, what if we tracked every single frame, what it took to render against every version of every shot, and start to compile that data and on a nightly basis predict our render load and have all of our local machines tie into this system and then say, okay, we're going to need 10,000 EC2 instances for 3 hours to get this workload done, and dialing that around. Okay, well, what if we only use 5? Then, it'll take 6, it'll take 8 hours. And so we're looking at AI and machine learning and how it can help us do that, to do predictive rendering. It's something that's really exciting and an exciting project we're doing internally. I talked about this a little early in the slide, but virtual infrastructure, new opportunities, and new ideas. It's kind of like a playground of ideas. And, the guys at Amazon are really great. They'll really help you. They'll come and talk to you, and they've got really great ideas, and they understand visual effects. That's a key component there. It's tough when you talk to different vendors and people who really don't know visual effects, and then they make assumptions about your workflow, and it's like, well, that's not really, this is how it works. Chris and his team, they understand VFX, and that's refreshing for somebody like me. And then, the slide I showed about television content changing, that's not just in the States or here in North America, that's globally. There's an explosion of content being created around the world. And being in the cloud, having cloud infrastructure allows a company like FuseFX to think globally and to think, okay, what if we need to be in different markets? What if we need to set up in Australia or London or China or different parts of Canada or South America? And it gives us the ability to think about that with a little more ease, with a little more, yeah, we can do this because we're on Amazon, we're backed by this big cloud provider, they exist everywhere, and we can leverage that really anywhere in the world. And so that's exciting for me. So last year at SIGGRAPH, an interesting story, a little kind of where we're at in the cloud and where we're going. Last year at SIGGRAPH, I had the pleasure of presenting about our initial cloud workflow, and I went home, and my neighbor, I saw him in the driveway, and he, oh, hey, Jason, what are you doing? Oh, I was at SIGGRAPH. Oh, what's that? And I explained to him what SIGGRAPH is, and he goes, oh, that's cool. He's like, what were you looking at? And I was like, oh, talking about the cloud. And he's like, isn't that like 3 years ago? He's an app developer. He developed apps for iPhones and Android devices, and I'm like, for you, yes. It is. It's very easy for you to adopt the cloud. For us, we have got a lot of infrastructure, it's more complicated, a lot of data. And he's like, oh, yeah, I get it. And I remember that because it's like, where are we going to be in 3 to 5 years from now? Are we going to be saying the same thing? Are we going to be saying, Chris and I were just talking at breakfast about, in 3 to 5 years, remember when we dealt with, on-premise infrastructure and this idea of a limited capacity, and boy, were we crazy, because now we're in this world of limitless capacity, and that's where we're going. Companies like Fuse are, trying to lead the charge in that, and we're really excited about other people in our space adopting the cloud and pushing this technology and pushing it to serve everybody and to serve this world of content creation, visual effects, and media and entertainment. It's a really exciting time to be in this business. So thank you. I appreciate.
Thanks, Jason. So I think that's the presentation. I want to thank everyone for joining us. If you have any questions, you can throw them up right now while I'm up here, or grab us on the way.
Normally from a fixed prem, you're going to have a fixed pipe to the cloud. Are we looking at like SDN to increase that capacity on demand?
So what we've done with our customers, we've partnered with people like SohoNet to increase capacity to infrastructure. I know that Jason added, maybe you could talk about that for a sec, but scaled up his infrastructure recently. We had a customer who literally added a second film to their animation pipeline, and so they ordered a direct connect and got that up and running in pretty short order. We also have Snowball. Are you familiar with Snowball? No. So that's a physical device storage that you can actually ship. There's this company, Amazon, that has shipping and stuff, logistics. So you can order it and get it shipped to you, and then copy a ton of data to it. And we actually have something called Snowmobile, which is like supports exabyte size or something like that. So, we had a customer who had hundreds of terabytes. Their pipe, was going to take them 11 or 17 days or something to synchronize the assets. And they basically wanted to shift everything and do a whole bunch of sequences on the cloud. And so they use Snowball. And then the incremental daily changes that artists do, depending on the size of your studio, can be massive or can be not as massive. So if you're a studio with 3,000 artists or something, and you're going to be churning through hundreds of terabytes an hour or a day, or petabytes a day, then you probably want to increase your pipe. But this is where desktops are coming in and virtual workstations. What we're seeing is even with small, medium-sized studios or larger ones like Jason's, and even the really large ones, they're saying things like, "Oh, I have to build an office in Montreal." And we're like, "We have a data center in Montreal," and it's bam. It's like we're going to start a virtual studio, and we're not going to build the infrastructure. So storage becomes a non-issue. But yeah, if you have an existing infrastructure, do you want to talk about scaling up your storage?
Yeah. I mean, he said a lot of it, but that pipe between your on-prem and your cloud is critical. And you have to, we structure it in a way where, we analyze how much we need, and that's the bandwidth we have. But we're not set up to scale that bandwidth. And we just kind of leverage that bandwidth and transfer files, making sure we're maximizing the throughput, that our transfer mechanisms are using that pipe as efficiently as possible. And, it still is a limiting factor there, and something we just have to manage. It becomes a problem with larger data sets. And every render on our farm, we know what those data sets are, and so we'll analyze everything and go, okay, well, these smaller ones are easier to transfer, so let's put those up and maybe let the localized infrastructure run the bigger ones.
How big was your pipe on the day that everything fell over and you had to scale up and get everything done in a few hours?
It was 500 megabits, so it wasn't that big. And that was, luckily we didn't have to transfer petabytes of data to the cloud in that instance. And that's not typical in our world. And most of the time, the source imagery that you're using or the source files that you're using for a render, sometimes they change, but normally they don't. And so you can pre-stage data and just, it becomes a data management process and how to best work with that in any particular situation. And then, yeah, desktops in the cloud. Once you're there, then you don't have to worry about it.
Anything else?
Yeah, I was just wondering, without mentioning specific numbers, how does your compute cost versus your storage cost kind of balance out, as a ratio?
I mean, the compute is the primary expense there. The storage is a very small fraction of that.
Right.
Yeah.
Okay.
I don't have less than 10%.
So just comparing on-prem versus bursting. Obviously, with an on-prem solution, granted, it doesn't scale as dynamically, but the costs are fixed, right? So you can predict and plan that. How do you, when you're bursting and dialing up and dialing down, does that pose any challenges to budgeting and working out the financials for
You definitely have to pay attention to those costs, because you don't want things to run away on you and then you get a massive bill at the end of the month and become surprised. So we debate and have controls in place to say, okay, do we need the cloud? Why do we need it? Okay, are we going to turn it on? How big of a workload are we going to turn on? So it just becomes a management function to make sure you're staying on top of those costs, creating alerts. I mean, you can set up in your environment any kind of alerting email at any level of cost. So I did 500, 5,000, 10,000, and all the way up, because I want to know. So we just keep track of it.
So one of the things that AWS has is we've transitioned hundreds of thousands of entities and companies and businesses to the cloud. And so there's a cloud economics team, total cost of ownership, people that understand this stuff. And most of the customers that we have today are using AWS as sort of supplement. Even if they're adding 9x or 10x the performance for 5 weeks, they're shutting it all down to zero. But what I think of the future is really going to be is a combination of something like a reserved instances. So those are like, I said at the beginning, like machines that you would purchase on-prem, but they're on AWS. And because you're committing to a spend over a period of time, they're discounted even beyond public pricing. And so we have programs like EDP and MAP, which are information is available online to help migrate workloads. But so if people are thinking like, well, do I add 100 machines and then burst up an extra 10, 20, 30%? Then the question is like, well, why don't you add those 100 machines on the cloud, and then you don't back yourself into a corner later, because you can always the data's there, the scalability's there. One of my customers came to me, and I think I have to wrap this up. I'm getting waved, and they said to me, I did the simulation, I built all these caches, I had 150 terabytes, and my on-prem infrastructure couldn't scale, and I have to double or triple it, help me get it to the cloud. And the only thing we could look at was like Snowball, because his pipe was so small in his facility. And I'm like, well, if you had simulated this on the cloud, you wouldn't have any problem scaling later, And he's like, yeah, I should have, And it's like that kind of, you can back yourself into a quarter on-prem as well. And studios have physically moved. I remember we had to physically move locations because we just were out of space and cooling and power. So anyway, that's if you want to add more questions, we'll be down here, and I'll let the folks take the stage. Thanks, guys.
Cool.